podcast, Michael Stonebraker talks about his journey into building database and database management systems. So stay tuned. So welcome everyone to Future of Data podcast. Today we have with us a fascinating guest. I think very few times we have an opportunity to talk to someone who's actually making an impact, who's actually causing this conversation to happen about where the data is heading to and where the data had been and what is going on with it today. So we have with us Dr. Stonebraker. A brief bio. Dr. Stonebraker has been a pioneer of data research and technology for more than 40 years. He was the main architect of the INGRES relational DBMS and the object-relational DBMS POSTGRES. These prototypes were developed at the University of California at Berkeley, where Stonebraker was a professor of computer science for 25 years. More recently at MIT, he was a co-architect of the Aurora Borealis stream processing engine and the C-store column-oriented DBMS and the H-store transaction processing engine, which became VoltDB, SciDB, Array, DBMS, and the Data Tamer data curation systems. Presently, he serves as an advisor to VoltDB, Chief Technology Officer of Paradigm 4 and Tamr Inc. Professor Stonebraker was awarded the ACM Systems Software Award in 1992 for his work on INGRES. Additionally, he was awarded the first annual SIGMOD Innovation Award in 1994 and was elected to the National Academy of Engineering in 1997. He was awarded the IEEE John von Neumann Award in 2005 and 2014 Turing Award, and is presently an adjunct professor of computer science at MIT, where he is co-director of the Intel Science and Technology Center focused on big data. With that, Mike, welcome to the podcast.
Oh, thank you, Vishal.
That's a pretty decorated background. I think it's an honor for us, our community, to have you contribute to this conversation. So why don't, as a start, you walk us through your journey? Like, what love to learn about how you got started into this and till yesterday or till maybe today.
Okay. Well, I guess at the very beginning, when I graduated from high school, I had 800 on my math SAT and 600 on my verbal SAT. It was pretty clear where my aptitude lay, and so I elected to go into electrical engineering, and back then I have plenty of gray hair. There really wasn't any computer science. And so I graduated from college with an electrical engineering degree. And that was exactly the time that the Vietnam War was going full blast. And so my options when I graduated from Princeton with a bachelor's degree was I could go to Vietnam and fight. I could go to jail. I could go to Canada, or I could go to graduate school. So it's kind of a no-brainer what I chose to do. And I would not have gone to graduate school in other circumstances. And so I went to the University of Michigan in computer, basically in CS. And it was by then obvious that CS, computing was where the future was. And so I became a computer scientist in graduate school. And when I got my PhD, which was safely when I was 26, and the Army didn't want me anymore, then the University of California at Berkeley hired me as an assistant professor. They thought I was going to do research applied to the national needs, but it was a big deal way back then, which was apply algorithms to siting fire stations, to scheduling work in civil courts and all that sort of stuff. And I started doing that, and I figured out it was really hard. You needed a lot of data, and it was really dirty. And we can come back to that later on. And so a colleague at Berkeley, Gene Wang, said, why don't we read this paper by Ted Codd, which was his 1970 pioneering paper on relational databases. And it became crystal clear that the other option, which was the codicil proposal, we read that too, and we were trying to figure out why anyone would ever propose that. Whereas the relational model was clean and simple, and we immediately said the obvious answer is to build a relational database system. And neither Gene nor I had any background in building large software systems, but that didn't deter us. We just started doing it. And so that's where INGRES came from. And the one thing that happened in INGRES, which I have no idea why we did this, but most academic prototypes build the system to where it just barely works. It can run 5 or 6 queries, do a fancy demo, and then they go on and do something else. For some reason, we continued doing INGRES to where other people could use it as opposed to just us. And so we had about 200 users of INGRES, in the late 70s. And about that time, Larry Ellison said, well, my system, Oracle, is 10 times faster than INGRES. And that was a pretty rude thing to say, since Oracle didn't even work at all. So it became clear to me that the only thing we could do to make a real difference was start a company, because as an academic prototype, there's just a big limit on what you can do. So we started INGRES Corporation in 1980, and what followed was the INGRES versus Oracle wars. And we had a wildly better product technically, but of course that doesn't really matter. So, and Larry Ellison is a master of deception. So lying to your customers and then what's called scorched earth, which is if he thought he was going to lose a deal, he would cut the price to 0 to try and keep the winner from getting any revenue. So in my opinion, we were competing, we were being honest, and that's not the way to sell software against Larry Ellison. So anyway, INGRES was reasonably successful. Oracle was more successful. In my opinion, the key thing that happened was INGRES was beating Oracle, and was growing faster than Oracle until 1984, which was a company worth 4 years old. And then IBM released DB2. And DB2 ran SQL, and even though Quell was a better query language, everybody agreed. So Larry had SQL, and we didn't. And although we got SQL within 12 months, that intervening 12 months was the difference between being number 1 and being number 2. And there's a thing called the America Cup strategy, which is if you're the boat ahead, you do whatever the boat behind you does, and that boat will never pass you. And so Larry very successfully applied the America Cup strategy, and so INGRES could never catch Oracle. So eventually INGRES got sold, and eventually got sold to Computer Associates and has been available for a long time. It's still the backbone behind Open Road, which is a very successful 4GL product that was originally written by the INGRES folks. So in sort of by 1983, it was, in the 70s, the only market was business data processing. So Oracle and INGRES, and for that matter, System R and DB2 were singularly focused on the business market. So the research community in the early 80s said, wow, this relational database stuff looks really terrific. Why don't I try it on computer-aided design? Or why don't I try it on library automation? Or why don't I try it on GIS? And relational database systems laid an egg in all these other markets, just disastrously. And so we started looking at GIS, and it was pretty clear that GIS required points and lines, polygons, line groups, all that stuff. And that didn't work worth a crap when the basic data types you had were integers, floats, and character strings. And the simulation of the types you wanted on top of the basic business data processing types was disastrously bad performance. So I guess the key idea behind PostGRES was, let's have user-defined types so that if you want points, lines, and polygons, they can be added to the system as basic types, along with their associated functions, point and polygon, distance from a line to a line. And to me, that was the key thing in PostGRES that made a gigantic difference, which is you didn't have to be constrained to business data processing, made relational database systems useful in a whole variety of other areas. And so we built PostGRES again. We got it to where it worked for us, and we got it to where it worked for everybody else. It got commercialized as a system called Illustra. Illustra was eventually bought by Informix Corporation in the mid-1990s. We thought selling to Informix was a really good idea because by then, PostGRES Illustra had the following horrible catch-22. So it was clear that PostGRES / Illustra would work great on GIS. And we had a commercial quality GIS type library. But what happened was when we went out and tried to sell that to customers, they all said, we don't want your type library. We want the GIS from ArcInfo or MapInfo. We want those guys' stuff. So I made the pilgrimage to Redlands, which is where ArcInfo is headquartered, and met with Jack Dangerfield. And I said, we have this absolutely great proposition for you. All you have to do is put your GIS, into Illustra. You'll get queries, you'll get persistence, you'll get transactions, you get all this wonderful stuff, and you can run all your current stuff. And isn't that a great idea? So Jack Dangerfield looked at me as if I was crazy and said very simply, how many customers do you have? And I said, well, about 50. And he said, come back when you have 5,000. So he looked at sort of type extension and databases as another market for ArcInfo. And he said, when you have a big enough market, I'll be interested. From Illustra's point of view, our customers wanted his stuff. So there's a catch-22. We couldn't get enough customers because we didn't have the type libraries, and we couldn't get the type libraries because we didn't have enough customers. So the answer to that catch-22 is sell yourself to somebody big. And so that's what happened. Illustra got sold to Informix, and Informix then ran with the product. They had a whole bunch of internal problems having nothing to do with Illustra, and eventually went into decline. But meanwhile, we had the academic version of Postgres. It still existed, and the commercial version was totally separate. So Illustra was totally separate from the University of California version of Postgres. So a happy accident was a collection of programmers, that had nothing to do with Berkeley, picked up the academic version of Postgres, which by then ran SQL, and ran with it. And that's the system that you download from the web today. It's arguably the largest open source enterprise-oriented relational database system on the planet. It's an ideal example of how open source can be wildly successful. So Postgres is supported by this ad hoc community who are doing a fabulous job enhancing it with additional features, and it's a fabulous system. If you want a free open source database system, Postgres is very reliable, very fast, high quality product. Please use it. So it turned out, the lasting version of Postgres was not the one we commercialized, but the open source one that the community picked up and has nurtured all these years. So that was the story of expanding relational database systems to other markets. What then happened was the data warehouse phenomenon took off. And so everybody on the planet built a data warehouse in the late 1990s or early 2000s. And, say the first guys to do this were all retail folks like Walmart and Kmart, those guys. So Walmart records every item that goes under any wand in any Walmart store anywhere in the world, and records a transaction record, who bought what, where, when, in a giant warehouse in Bentonville, Arkansas, and keeps item level data for, I think, 2 or 3 years these days. So this is a very different market from anything relational database systems had been applied to earlier. This is historical data, and it's query only. Load new data, and then it's read only. So it turned out I had the lucky accident to realize that if you took a record-oriented relational database and you rotated your thinking 90 degrees and you made a column store instead of a row store, that it was an order of magnitude or more faster than a row store. So we built a prototype at M.I.T. where I was by that point, called CStore, which you mentioned earlier. And that got commercialized into Vertica. And Vertica was wildly faster than the row stores, just wildly faster. And so it has caused every data warehouse product on the market to painfully switch from being a row store to being a column store. And so all the data warehouse products today, with the exception of Oracle, which is still a row store, are now column stores. So Oracle claims to be a column store, but that's not true technically. And so my favorite vignette is, if you want to know the platform on which Oracle runs the fastest, the answer is a 35 millimeter slide projector or your PowerPoint presentation. So anyway, the only real data warehouse products are column stores these days. So, and they've had a long run. They're still the most prevalent. Their data warehouses are all column stores, and there's half a dozen vendors with very good products at this point. And I consider the data warehouse, column store data warehouses to be a huge success, just giant success story. So the next thing I got involved in is a VC told me, why don't you build a new OLTP database system? There should be a better way to do it than these 20-year-old row stores, which is what the commercial market was selling. So I guess, the insight was that if you said, the insight was that if you looked at where relational database systems spent all their time when processing transactions, it was in the concurrency control system. It was in the crash recovery logging system. It was in multi-threading because all the latches, people had to wait on latches, and it was in the buffer manager, keeping track of records inside buffer pages that were in main memory. And a relational database system spent only maybe 10% of its time doing useful work. The other 90% of the time was all this other stuff. So that caused us to build HStore, which was oriented toward getting rid of the 90% of overhead. And so it had to be a main memory database system because otherwise the buffer pool kills you. It had to have very high performance, different concurrency control and crash recovery than the previous systems. And it had to be single threaded because otherwise you spend all your time on latches. So that was HStore, which got commercialized into a system called VoltDB. There's been a bunch of other very high performance main memory database systems. The market hasn't exploded because I guess in my opinion, the number of people who want to do 1 million transactions a second, which can be done by these high performance systems, there aren't that many of them. I expect the future will be bright for this class of database systems because the Internet of Things, everything on the planet is going to get sensor tagged and it's going to report its state or location in real time. And that's going to up the volume of transactions dramatically. And I think the future looks bright for main memory alternate OLTP systems like VoltDB and others, but they haven't sort of exploded into the mainstream just yet. Then the next thing I got involved in is if you look at genomics applications, so the human genome is 1 billion or so base pairs. So if you want, and in the process, we're in the process of sequencing everyone on the planet. And, the British government has a project to sequence everybody in Britain. And so imagine that you want to sequence 50 million people. So that's a giant array with 1 billion base pairs going along the horizontal axis and 50 million people ID going up the vertical axis. That's a giant array. And it doesn't look like a table. It doesn't look like a column store. It doesn't look like a row store. It's an array. And what people want to do, operations on arrays are linear algebra. And so people want to do singular value decomposition, principal component analysis of big arrays. And if you try and use a relational database system, it really sucks on this sort of stuff. So we said, well, the answer is you want a native array database system. And so we've built one, SciDB. There's a couple others on the market. And they're starting to get traction in the genomics space, and they're starting to get traction in the time series space. It's still very early, but I think there will be a big opportunity for array database systems going forward, especially in the genomics world and especially in time series world. The last thing I wanted to mention is off and on I've been interested in data integration, because the problem is upstream from any data warehouse, there are 50 data sources sort of, trying to load data downstream. And the trouble is enterprises are siloed into business units so they can get stuff done. And so you create a database system, I create a database system you create it for your data, I create it for my data. The schemas are never the same, never. And so it's a huge problem to do data integration, which is, we built a prototype at MIT that does this sort of stuff. It got commercialized as a company called Tamr. Tamr is addressing just a gigantic open wound, in enterprises, which is putting disparate data together for business value. My favorite example is Toyota Motor Europe, which turns out to be a Tamr customer. Toyota, their distribution in Europe is by country, except in Germany it's by canton. So if you buy a Toyota in Spain, well, your customer records are in Spain, all that stuff is in Spain. You move to France, and that's a totally separate distributor. They know nothing about you. So if you move to France, take your car with you, Toyota develops amnesia. And they, of course, don't want to do that. So they are in the process of integrating 250 databases with a total of 40 million records in 30 different languages into what amounts to a big European data warehouse. But their big problem is data integration. The other thing I love to talk about is machine learning is just the rave these days. And so the trouble with machine learning, my favorite vignette is there's a company here in the Boston area called iRobot. They're the guys who make the automatic vacuum cleaners that run around your floor and clean up. And they now make an automatic lawnmower. So I talked to the chief data scientist at iRobot. And I asked her, how much time do you get to spend building your machine learning models? And she said, well, I spend 90% of my time finding, cleaning, and integrating the data that's required to build my models, leaving me 10% to work on the problem at hand. Of that 10%, I spend 90% fixing my cleaning errors. She said, I spend 1% of my time doing machine learning and 99% of my time doing Hmong work, basically doing data integration. So data integration is what's killing everybody. So in my opinion, right now, the data warehouse market is well understood. There are a whole bunch of products that are doing OLTP. Doing core data management is not the big pain point in enterprises right now. It's doing data integration, as well as finding enough machine learning people to to apply machine learning to their problems at hand. So that's sort of a thumbnail sketch of my career in half an hour.
This is fascinating.
That's your turn to talk.
No, I think it speaks to our listeners and viewers. It speaks about the volume of experience that you bring on the table and how your work has contributed to a lot of things that we use in our day-to-day database operations. So I do appreciate each and every bit of your contribution in helping us with this so-called database and database management system. So thank you so much. So I'm curious to understand, during your early days, a brilliant guy with an advanced degree, why join academia? Like, why not go to corporate and make a more accelerated impact? Like, what caused that decision?
Well, remember, it's 1970. It's not 2019.
Hmm.
In 1970, if you got a PhD, you were basically expected to go to academia.
Interesting.
IBM research was in its infancy. There was, shell research. There were very few industrial research labs. That's been a huge uptake, since then. So the answer is, it never occurred to me to go to an industrial research lab. There were no startups in 1970. That was not an option. So you young people that don't have gray hair, you see a very different world than I saw in 1970.
Interesting. And what's your experience? So you have seen database maturing through generation of progression. Like, what has been your observation on how businesses are utilizing this data, and how they used to and how they do today? What's your perception on how are they doing a good job? They could, like, what's your take on that?
So my reaction is that most enterprises have completely screwed up their data management strategy. Say it's very well understood how to build a good schema. You can open any textbook on data management, and they'll tell you exactly how to do it. And people don't do that. And people, if you're going to use a database system and you want it to perform well, you've actually got to understand a little bit about query optimization and a little bit about storage management. And so at the very low level, people misuse data management on a routine basis, which is mostly they're not hiring skilled practitioners, either because they can't find them or whatever. So I think my first advice to anybody in an enterprise setting is find some very sophisticated database talent. You don't need very many of them, but find a few to keep you out of trouble. So that's my first observation. My second observation is, if you don't have one, hire a chief data officer and empower that person to come up with a data integration strategy. Because I find too many people have the following data integration strategy. I will drink the Cloudera Kool-Aid. I will set up a big data lake and I will put Hadoop on it. I will put all my files into this data lake and life will be great. Well, that generates a data swamp, because without an integration strategy, you've got all these silos. The data doesn't just line up, and you better figure out how to do it. The favorite vignette I like to say is Mark Ramsey is the chief data officer of GlaxoSmithKline, GSK. So when he was hired, he said, I'm delighted to come be CDO for you guys, but you have to give me read access to every single database that GSK has so that I can figure out what my inventory of stuff is. Without that, I have no chance of developing the strategy for this company. So hire a CDO and empower him to actually do data integration. I guess those are the two biggies. My third biggie is that everybody is going to move everything to the cloud, either sooner or later. So Mark Ramsey already has a cloud strategy, even though he's only been at GSK like 2 years. And so everybody's going to move everything to the cloud, because the cloud, well, it turns out if you put up a data center, well, if I put up a data center, then I located in Cambridge, Massachusetts on raised flooring. If Microsoft Azure puts up a data center, it turns out what they're currently doing is it's shipping containers that they stuff with boards. There's power in, chilled water in, and internet in, and that's it. Otherwise, it's sealed. They stack a whole bunch of these shipping containers in a parking lot. Walls and roof optional. They're only there if you need them for security. So raised flooring in Cambridge versus shipping containers in the Columbia River Valley, who's going to be cheaper? So these guys are going to win on price. Now, right now, it's not totally clear, but I think the internet is going to be one gigantic race to the bottom as we all move to use that technology. So I think it's guaranteed to be cheaper than what we can do. And so just having a plan that moves everything there in some organized way is going to be crucial. You have to understand the cloud providers in order to do good things there. So for instance, AWS, which I spent some time benchmarking, there are these things called t-shirt sizes, which is resource bundles of of network performance, CPU performance, memory size, that stuff. There's like 80 of them, and you have to figure out which one you want to use. So there's a lot of stuff to learn to get smart about the cloud. So that would be my advice to enterprises is get cloud smart, get data integration smart, and hire a CDO to come up with an integration vision.
I think so. You're raising a very interesting argument, right? So I think recently I was talking to one of the CDOs of one of the banks, and he was telling me that, Vishal, right now there are like thousands of vendors selling their own suite of database solutions, and each of them are now attacking a particular application and at a very cost effective that it's hard to resist many times. And we bring them on board, or someone from some team, some shadow group brought these sort of random database use cases on board, and it makes the life a living hell for the entire organization. A lot of data sources, a lot of data silos. As you rightly pointed out, there's a lake, then it turned into a swamp. You can't manage that. So, and the bigger you are, the messier it gets. So what would be your very tactical suggestion that someone who's actually leading the organization could execute on to stay sane? I think that's what would you say to those guys?
So I think it's like, I mean, everybody is dug in pretty deep in legacy mess. And so you're saying, what would be my reaction to being in such a data mess? So the answer is, I'll give you two answers. One answer is go work for somebody else. But the real answer is that it's the job of the CEO or the CIO or the CDO or a committee of senior database experts to come up with a strategy to dig yourself out. Because I don't see anybody with such a strategy, which is to just say they kick the can down the road, which means they're dug in even deeper next year. See, so I think that you have to come up with a strategy to extract yourself it may take you a decade or two, but otherwise, I think you're going to lose. So if you look at the banks, they're dug in pretty deep. And if they don't extract themselves, then the non-bank banks, like Apple and Charles Schwab and all those guys, are going to eclipse them. So if you don't dig yourself out, sooner or later you're going to lose. And so I think it's imperative to hire a really smart small team and pay them and pay up to get them, and then charge them with, how do I get out of this mess?
I thought I was sick of home, but actually I was homesick. Never really knew that I would have to grow up so quick. I'm so uncomfortable, don't know anybody here. Just a couple dudes that I met once, that's it. And I go into the booth feeling nervous. Got butterflies in my stomach like I'm so worthless. Is the mic on? I don't know how to work this. Inside I'm breaking down, I hope I'm not up on a